Hey guys, so today we are going to be learning a very specific type of map, and that's called a topographic map. Topographic map. Sometimes you may hear people call them contour maps. That's because pieces of it have to do with contour, and we'll talk about that in a minute, but they're called topographic maps. So what you're going to need today, we're going to do a little introduction activity so that hopefully it makes more sense. Topographic maps can look confusing whenever you first see them. So we're going to start 3D and then transfer it over to a map. So you're going to need a piece of paper. You are going to need a piece of floss and Play-Doh. So first what I want you to do with your Play-Doh, you can get it out, is, I already kind of did this earlier, you are going to shape it into some type of mountain or a hill. I need a 3D crustal feature. I'm going to make mine have kind of this little plateau at the base. Okay, so this is going to be my hill. It doesn't have to be anything fancy. If you want to spend just a little more time on yours, that's fine. Put it over on the side of your paper. So what topographic maps do is they show the shape and also the elevation of land surfaces. So this is going to be our land feature that we're going to look at, and we're going to actually go through and create a topographic map. So it's going to show us both, again, the shape and the elevation. So if you look at it from the top down in the video, it just looks like a big circle. Whenever you look at it from the side, you can actually see the shape and the elevation. So what I want you to do is get your mountain or your hill made, put it on the left side of your paper, and you're going to need something to write with. So what we're going to do is trace the base of your crustal feature. I'm going to call mine a hill. Okay. So there's the base. You can kind of see that I traced it. And I'm going to let you pick it up, but you need to just put it right back. Oh, I'm stuck to the paper. That might happen. That's okay. Just put it directly up front. Let's get this video focused. Okay. So what we just did was we drew a contour line. I totally spelled that wrong, so let's back up. I wrote contour, a contour line. Okay, contour line. This is our base, so if it's the very base, usually our elevation, what I want us to start at is 0 meters. It was sea level. I'm just gonna make this darker. It was the bottom of our base, okay? So what you're gonna do now is you're gonna take some floss, and you are going to slice off a chunk. I'm going to do about this much of the base of your mountain and just pull it all the way through, just like this. So now I'm going to take, it's like I'm sectioning it. So I'm going to take this section of my hill. I've already traced it. This section, I'm going to put it back, how it fits right in there. So now I'm going to trace this line again. Oh, I keep getting Play-Doh stuck to my pen. That might happen. It doesn't have to be super perfect. We're just getting a general idea today. I want to trace the bottom of your crustal feature. Pretty close. Okay, and then we're going to go through and do the same thing. Now, you see that there's space in between the first trace line and the second trace line. This is going to be called our contour interval. You can think about an interval as just a space in between two things. So our contour interval is how much space or how much distance or how much elevation is in between the two lines. For this one, I took out a pretty decent chunk of this model, so I'm going to say that this was 20 meters. So we started at 0. Then basically what I'm saying is that from this line I first traced up this line, if this were a real hill, I'd be hiking 20 meters up. So this line is going to be 20 meters. So then we're going to do the same thing. We had just traced this. I'm going to go ahead and use my floss to slice through another section of about the same size. So right here, after my slice, there goes the bottom. Put this back. Okay, so because I took the same amount out each time, this is still a 20-meter difference. You may notice in mine, my lines are closer together. That just indicates that it's getting more steep. If yours was not as straight up as mine was, you may have more space in between there. It just depends on every single crustal feature is different. So I'm going to take the same amount off. Number 3. So now I just have the top of my hill. Same thing, trace one more time. This Play-Doh will stop sticking to my pen, that would be awesome. Okay. Oh, we missed this spot over here. That's okay. Okay, so I started at 0 meters. My next contour line was 20 meters, which means my next contour line was 40 because we decided our interval, or the space between, was 20. So then 20 plus 40 is going to give us, this is 60. And this Play-Doh is messing up my pen. And then if you want to do it one more time, or if your crustal feature was really tall, you may have to keep doing a few more sections. This is just going to be the top of mine right here. Do this real quick. Okay. So we know that because my interval was 20 meters, 60 plus 20, this is 80. So it does not have to look perfect, doesn't have to be beautiful. Play-Doh sticks to the paper, it's okay. We're getting a general idea of what our topographic maps look like, and actually, you just created one. So this is exactly what a topographic map is. You're taking a 3D landform, which is what we had right here, and it's like you're cutting it into slices, and you're mapping it. So people use this all the time for hiking up in the mountains. That way, if somebody needs to be rescued, if you're trying to hike from point A to point B, you can look and see if the lines are super close together. You know it's really steep. You may want to find a place on the map where they're a little bit further apart. It's not as steep. So, real quick, on the other side of your paper, the contour line shows the change in shape or elevation. Your contour interval is the difference in elevation between any two contour lines. So this is just the difference in elevation between two contour lines. For my example, I just decided that ours was 20 meters. Every contour map is different. It could be 1 meter, it could be 100 meters, but they will give you number indications. It'll either have a key that says the contour interval is, and it'll give you the distance, or you will have to use a map and look at it. And so if they only gave me 0, 20, and let's say 80, I would have to go through and count and check, okay, well, is my interval 20? Would it be 20, 40, 60, 80? And you could figure it out that way. So make sure all of this is on your paper, put your name on your paper, and get ready to turn it in.